Hi everyone. I got some questions about some of the problems from the practice test over the weekend, so I thought we could go over a couple of those. So here's one, number 6, simplifying this sum of rational expressions. As always with anything having to do with rational expressions, it works the same for rational expressions as it does for fractions. And since these two rational expressions have different denominators, we need to get a common denominator to subtract them, just like with fractions. So looking at these two denominators, the one on the left has the denominator is k minus 1, and the one on the right, the denominator is k minus 1 squared. So the least common denominator between these two is going to be k minus 1 squared. It's just like you had a fraction, one of which had 3 for the denominator and the other had 9 for the denominator, so the least common denominator is 9. It's just like that, except with polynomials instead of numbers. Okay, so now that we know what least common denominator we're aiming for, k minus 1 squared, we need to get both fractions to have that denominator. The rational expression on the right already has that denominator, so we'll leave that one alone. But the rational expression on the left doesn't have that denominator yet, so we need to make that denominator appear. And to do that, we can multiply the numerator and denominator here by k minus 1, like this. Right? You can multiply the numerator and denominator of any fraction by anything, as long as it's the same thing. Okay, now in the numerator, we can multiply this out. We get 2k minus 2. Now the denominator, k minus 1 times k minus 1 is k minus 1 squared. Oops, there we go. Minus, and this one on the right, remember, we were going to leave alone because it already had the denominator we wanted, so negative k plus 4 over k minus 1 squared. Okay, now that these have the same denominator, we can go ahead and subtract them. So 2k minus 2 minus negative k plus 4, like this, over k minus 1 squared. All right. Now, in the numerator, we can simplify all of that stuff in the numerator. One thing to notice here is that this minus sign in the middle that came from the subtraction, that's going to end up distributing over the parentheses here. And that's a key point. That's really easy to forget. Okay, this minus sign is going to end up making the k plus and the 4 minus. Okay? So we end up with 2k minus 2 plus k minus 4 all over k minus 1 squared. Now we can combine like terms in the numerator, so 2k plus k, that's 3k, and then minus 2 minus 4, that's minus 6, all over k minus 1 squared. Okay, and now, as always with rational expressions, once you think you're done, you really should factor everything to see if anything cancels. It's possible that when we factor the numerator, we might get a factor of k minus 1, in which case we could cancel a factor of k minus 1. So let's check. In the numerator, both terms are divisible by 3. So if we factor out a 3, we get 3 times k minus 2 all over k minus 1 squared. Okay, so in this case, actually nothing does cancel, but you do have to check, just in case. So our final answer here is 3 times k minus 2 over k minus 1 squared. If you wanted to, you could multiply out the numerator and denominator again, but usually I don't unless I need them to be multiplied out for some reason. So that's it for number 6. Let's have a look at number 7. Got it over here, all set up and ready to go. So solve this equation for n. when you have an equation with rational expressions, one way to start, this isn't the only way to do it, but one way to start is just multiply everything in sight by the least common denominator, and that will have the effect of getting rid of all of the denominators, and then it won't be an equation with rational expressions anymore. It'll be just a polynomial equation, and we know how to solve those, factor and use the zero product property. So let's start out by multiplying by the least common denominator. Well, first we need to figure out what is the least common denominator. Let's see, over here on the right we have a factor of 6, and on the left we have a factor of n, and we have a factor of n minus 1. So let's multiply both sides of this equation by 6n times n minus 1. So on the right and on the left. 6n times n minus 1. Okay, so we're going to end up distributing this to everything here, here, and here, right? So we get 5 over n minus 1 times 6n times n minus 1 plus 1 over n times 6n times n minus 1 equals 7 over 6 times 6n times n minus 1. It's sort of a lot of writing. You don't necessarily need to write this step out completely. I'm doing it just so that you can see how everything cancels. Okay? Because a lot does cancel here. Indeed, that's the whole point. That's the whole reason we multiplied by the least common denominator. So in this first term, the n minus 1 here cancels that n minus 1 right there. In the second term, this n here in the denominator cancels the n there. And then on the right-hand side, the 6 there in the denominator cancels the 6 in the numerator. So let's see what we have left. So in this first term, 5 times 6 times n, that's 30n plus, in the second term, we have 1 times 6 times n minus 1, so that's 6 times n minus 1. And then on the right-hand side, we have 7 times n minus 1, so 7n times n minus 1. And you can see all of the denominators are gone now. So all we need to do is multiply everything out, move everything to one side, factor, and so on. So let's do that. Let's see, we get 30n plus, so here we need to distribute this 6 here, 6n minus 6. Then on the right-hand side, we need to distribute this 7n. We get 7n squared minus 7n. Okay. On the left-hand side, we can combine these n terms. So we have 36n minus 6 equals 7n squared minus 7n. All right. Now we can move everything to one side. I'm going to move everything to the right just so that my leading coefficient on the n squared term is positive. That's just how I like to do it. So let's subtract 36n and then add 6 to both sides. So on the left-hand side we get 0. On the right-hand side we get 7n squared. Let's see, negative 7n minus 36, that's negative 43. Oops, negative 43n plus 6. Okay. Now we need to factor this, and this does factor, I think. Let's see what we can do. So 7 is prime, so it's going to be 7n here and n there. Because there's a plus 6 and the middle coefficient is negative, we know we're going to have negative and negative. And then we need factors of 6 that make this whole thing have a, when you multiply it out, you get negative 43 in the middle. And the only way to make that happen, I mean, the only way to get a number that big is to have the 7 over here with the n multiplying the 6 on the right. So let's try this one. And if you multiply this out, it works. 7n times n is 7n squared, and then 7n times negative 6 is negative 42, and then 1 times n, one more negative n, so that's negative 43n, and then negative 1 times negative 6 is plus 6. So this is how that factors. And now we can use the zero product property. So we have either 7n minus 1 equals 0, or n minus 6 equals 0. Okay, so here we can add 1 to both sides. Here we can add 6 to both sides. And we get 7n equals 0, or n equals 6. Okay, and then finally, I'm sorry, not 0. This should be a 1 right here. Sorry about that. And then last step, divide this 1 by 7 on both sides. We get either n equals 1 over 7 or n equals 6. And that's it. We're all done. I'm going to try to make a couple more videos this afternoon, but we'll see if I have time. Bye.